going to start over here again. So little rewind to the tape, so to speak. So let's just get rid of all this stuff. You get to see it one more time, Catherine. Aren't you lucky? All right. So back to what we were supposed to be doing here. So so they tell us that suppose 8% of college students are vegetarians. Determine if the following statements are true or false and explain your reasoning, okay? So in part C here, what they've got is a random sample of 125 college students, so that's N, where the sample produced 12% of them were vegetarians, and they want to know, would that be considered unusual given what the proportion, the population proportion was supposed to be, which is 8%. So before I get going into the details again, when we're talking about usual versus unusual, let me stop for just a second and remind ourselves how to determine what P is equal to and what P hat is equal to. So P, remember that this one right here, the P, this guy right here goes with the population. That's a population value. The P hat, that's a sample value. So that comes from a sample, all right? Okay, so as far as what we got out of our statements here, in other words, what they gave us in the problem, the 8%, the 0.08, that's P, that's the population. Whenever you see the word suppose, then they're telling you, consider this the population value, pretend that this is P. The P hat, well, that's coming right here because that came from a sample. So as soon as you see the word sample and a percentage that follows that, you're pretty much guaranteed that that's going to be your P hat.
Okay.
All right. So, and then also they gave us our N, our sample size here was equal to 125. All right. So now they want us to say, would it be considered unusual? That's what we're looking for. Well, to be considered unusual, if you think about the distribution of P hat, once you do the reading, you'll see that it's distributed in a standard normal distribution. Okay. In other words, we use the Z again. We're going back to Z and not T. And so we're going to use for our test statistic a Z value. And we know from our earlier work that 95% of all of the Z-scores fall within plus or minus 2 standard deviations of the mean, which in this case is 0, all right? So if we get a Z-score, if our Z-score in absolute value is greater than 2, that means, in other words, if it falls up here or it falls down here, then what we're going to say is that these areas right here, those areas in the bottom and the top, those would be considered unusual. Anything that fell in these shaded regions, let's shade them in purple just so that we can stay consistent with my lines. Okay, so anything in the purple region would be considered unusual. All right, so how do we calculate that? Well, our Z-score is going to be equal to P hat minus P divided by the square root of P times 1 minus P over N. Now, that's the specific formula for the sample value of the center or the mean subtracted from the population mean divided by the standard error. So remember, Z-score was X minus mu over sigma, all right? Where mu and sigma are from the population values and X is your observed value. When you're working with the central limit theorem, then that's X bar minus mu over sigma divided by the square root of N.
Yes.
Okay, well, in this case, we're working with P, and so in the case of P, that means it's P hat minus P over the square root of P times 1 minus P over N, which is the standard error for this, okay? All right, so let's get that other formula out of the way so it doesn't cause confusion, because we're not going to be using that guy right now. We're going to be using the one that I've got. All right, so we need to go in now and just fill in the blanks, okay? Put in all the proper numbers. So P hat here, let's see, what is our P hat? That's 0.12. Our P is 0.08. That's all up in the numerator. And then down here in the denominator, we've got the square root of P times 1 minus P over N. Well, again, the P is the 0.08 times, well, let's see, 1 minus P would be about 0.92.
Okay.
These two numbers, always have to sum to 1. That's one way of thinking about it. You're taking a product in here when you're doing it, but they have to sum to 1, all right? So, and then that's all divided by n, which n is equal to 125.
Okay.
So what we need to do now is go plug all that crazy arithmetic into RStudio so we can see what we get. So I'm just going to go ahead and do it in the console. I just need to do the arithmetic someplace. You can even do it on your calculator if you wanted to, but let's go ahead and do it here. So what do I got to do again? Well, let's see. I got to get in that numerator, so I'm going to enter parentheses for that. So to get the numerator, I'll have to have parentheses. So that's going to be, let's see, what were my numbers again? They're going to be 0.12 minus 0.08. Okay, so that's the numerator. Now in the denominator, we're going to come back. We're going to have a square root, and that square root is going to be SQRT parentheses, and now I got to put my numerator in here.
0.08.
Yes, it's 0.08, and now times. You have to use. That's where Damien was having some mistakes earlier. R insists on explicit operations. Juxtaposition doesn't work. In other words, if I do 2 parentheses, 3 parentheses, and expect it to multiply, it'll throw an error. It doesn't get that. You have to use that times multiplication symbol, which is the shift 8 for the asterisk. Okay, and then that is times what? 0.92 or just 0.92?
0.92.
Yep, and then we're going to divide that by 125. So that's what's in the square root, okay?
You put 124, did you?
I did, didn't I? It's because I don't know how to type. All right. So it comes out to 1.65 if we round off to 2 places, which is within, if we go back to the drawing here, go back to our drawing, notice it didn't fall outside into the 2 standard deviations. It fell all nice and happy in here, okay? So it's like right there. So what that means is since we round that off to 1 point, what was it again? 1.65 or 1.648. Let's go with that. 1.648. Okay, so at 1.648, then the dot over there for approximation. Then what that means is that it's not unusual. So nope. So this statement right here would be false. Is that making sense, Catherine?
So far.
Okay, cool. Well, that was the only one he asked me. Do you want me to do any more of these?
I haven't looked at I haven't gone through all of the YouTube videos
Okay.
yet, so I don't really know what my questions are.
Right, yeah.
Um,
Yeah, well, and I worked a fair number of sample problems in the lab. So if you go watch through those videos, you'll see how some of these are worked already. So
okay.
hopefully my sincere hope is those help.
Okay. Yeah, I mostly wanted to ask you about the question that I already asked.
Yes. Right. Okay, perfect.
Yeah.
Well, if that's it, then it works for me, because I tell you what, I got a ton to get home and get back to tonight. So we can call it good here if I've taken care of your questions. And I know I've taken care of Damien now, so, and nobody else had anything else posted that I saw. Let me just go check the Q&A form real quick just to make sure I'm not lying about that everybody is getting their questions answered.
Yeah, I think I went to Eureka for my other questions, and I think I got them all answered.
Perfect. Perfect. Awesome. So who'd you work with?
Sorry, what?
Who'd you work with?
Let's see. I don't know anyone. I don't really know the names of the tutors.
Okay.
There was a guy with brown hair. He was really tall. I think he was one of the professors. And he was probably the most helpful.
Great. Good.
But Yeah, anyone who can talk to me about stats is helpful.
Yeah, unfortunately, not all of them have taken stats, so they're not all.
There yet.
Yeah, they're not quite as savvy with this stuff because most of us have an applied math degree, and so stats is kind of first nature for a lot of us. But for others of us, if they went more the pure math route, they probably didn't have as much experience with this stuff. So
I think I'm also finding that even if the tutors have taken statistics, they might not necessarily have experience with RStudio.
yes.
So that's another angle that I've been facing.
Yeah, well, that's the one that you definitely want to make sure you hook up with me. Or there are, but there are tutors there, like Dave Arnold or Mike Haley, that are quite versed in R, and they know it better than I do. So those are always good guys to get together with too. So yeah, it's about probably 30% of us that know what we're doing in R. Like Levi Gill knows. That's probably who you worked with. Would be my guess would be Levi, taller guy with brown hair, not too old, kind of younger guy.
Yeah.
Yeah, that'd probably be Levi.
Could you by any chance post a list of these tutors who have experience with R so that
yeah, I'll tell you what, I'll go in and look at the web page for the math lab, and I'll see what hours they're at, and I'll post that in a message to everybody.
That would be excellent.
Yeah, so you'll know if you're going down there, you're going to get somebody that's going to be there. And I'm down there Mondays from 12:30 to 1:30 also, so you can always catch me too. So
yeah, well, part of that problem is that I'm not always going down on Monday because gas is an issue for me.
Yeah, it's not cheap.
Yeah, and I have a considerable distance to come.
Yes, and so don't do it unless you absolutely have to. I mean, we can always make additional hours this way too, Catherine, if that works for you. Okay.
Yeah, I can try that. I did also find that someone on NetTutor had some experience